This is comparing fractions, and here's your bad fractions joke. Something you need to remember for basically everything we're doing in fractions is what each part of the fraction means. It's going to keep things a lot more clear if you remember that the denominator, bottom, tells us how or what type of pieces we're using. The numerator up top tells us how many pieces. So look at these two fractions for a minute and think about which one is bigger. So what represents a larger amount? Seems right away like 700 over 1000 represents a larger amount because those are both a lot bigger numbers. But just remember what the two parts of the fraction mean. The top tells us how many pieces, the bottom tells us what type of pieces. So in 700 over 1000 we have a lot more pieces, but they're very, very small pieces because this is talking about a whole that's divided up into thousands. The fraction on the left, 8/10, we're talking about a whole number that's only divided into tenths. So obviously those 8 pieces are much bigger pieces. So if I write 700 over 1000 as an equivalent fraction, that's the exact same amount, but it's a lot easier to compare to our first fraction. So that's what we're going to be doing with comparing fractions. It's just a matter of rewriting them so we get a better idea of which fractions are greater and which fractions are less, because it's not something you can tell all the time just by glancing at a fraction. Sometimes you got to do some math to be able to compare them a bit better. So one way to compare different fractions to find out if one is greater than the other is to use a number line. So the number lines you might be used to just count by whole numbers, but we can use them for fractions. So what you have to do is draw a number line that has a whole number, so 0 and 1, but then you can split that whole number up into whatever type of fraction you want and choose whatever fraction to split it up with based on what you're trying to solve. So you could just split it up into 2 halves or 4 quarters or eighths or tenths. It's a little bit trickier to split it up into a wonky number, like an odd number like ninths or fifths, but if you're careful with drawing, that can be done too. So step 1 would just be to draw a number line that's going to help you. Okay, so this is part of a question from your textbook. This is 7C on page 228. I just want to do this one as an example of how you can use a number line. So first you got to set up a number line that makes sense. So I'm just going to make this a bit bigger. So what we're looking at here, we have mixed numbers. And looking at the whole number parts, we have one has 5 as the whole number, we have 6 as the whole number, and 2 as the whole number. So I'm just going to pause this and label this number line in a way that makes sense to me. Okay, I've labeled it with whole numbers going up to 7, so each little hash mark on my number line represents one whole number. I have a bit of an advantage here because I can make my number line bigger and smaller, which is going to make this a little bit easier. When you're doing this on paper, you're not going to be able to do that, so please draw a nice big number line so that you'll easily be able to add marks and count on it and split these up into fractions. If it's too small, that's going to be really difficult, so probably a good idea to make these really big. We have lots of paper to do that with. So what the question asks you to do is to take these 4 mixed numbers and arrange them in order from greatest to least. For a few of these it's pretty obvious because you just have to look at the whole number. So 2 and 1/8, we only have 2 whole pieces. The other fractions, one has 5 whole numbers and one has 6 whole numbers, so they're pretty easy to arrange. I'm going to still take the time to put them on this number line just so you see how that can be done. So we'll start with the one that looks the smallest. Okay, I'm going to blow this up. So this fraction is a little bit more than 2, so it's between 2 and 3. So we want to mark this so we can easily find 1/8. Good way to do this is start with the half, so I've split it up into 2 halves. Now I'm going to split up each of my halves into quarters, and the quarters can be split up into eighths. So roughly now we have eighths marked on the number line. So 2 and 1/8 is going to be right there. That would be 1/8. Okay, let's move up the number line a bit to label my next fraction. So 5 and a quarter. Let's zoom in between 5 and 6. So this is 5, and then a little bit more, 1/4 more. So let's just add some marks on here so we can see where 5 and 1/4 would be. Start with the half, then cut each one of my halves into quarters. So now it's split up into 4 pieces, and 1/4 would be right about there. Let's just label that. So that is my 5 and 1/4. Okay, the next one's going to be a bit trickier because we have two mixed numbers here that are both somewhere between 6 and 7. And they're both different types of fractions, so it's going to be a little challenging. One good thing with number lines is you can split up your fraction one way on top of the number line and a different way on the bottom, and that really helps you to compare them. So let's just look. I have 6 and 2/3, so I'm going to, for the top, I'm going to split it up into thirds, roughly. That splits it up into 3 even pieces. So 2/3 is just going to be right here. So that's 6 and 2/3. We also have 6 and 9/10, so I'm just going to pick a different color here. And I'm going to split the bottom into tenths. Tenths are a little bit tricky. I'm going to start with 2 halves, and then I'm going to split each half into kind of 5 pieces. As long as they're roughly all the same size, this should be accurate enough. Okay, and 9/10 should be, we just count 9 of these, so 9/10 would be right about there. That's my 9/10. So 9/10 is a little bit bigger than 2/3. So let's just zoom back out and look at the whole thing. Now we've done all our labeling. We should be able to compare these and put them in order. So our smallest or least greatest fraction is 2 and 1/8, way down the number line there. And then next we have 5 and a quarter. And next after that we have 6 and 2/3, and just a tiny bit bigger than that is 6 and 9/10. So number lines can be really helpful for these types of questions, but you do have to be accurate when you label them and when you split up your whole numbers into fractions. Okay, number lines work pretty well for some of these, but certain questions can be pretty tricky to draw out, so we have another strategy for you, and this is to make equivalent fractions. So basically what you want to do is, any way you can, make all your fractions the same type of fraction. So this is number 2 from your textbook. I'm looking at these 4 fractions. I want to compare them from least to greatest. We have 3 mixed numbers and 1 improper fraction. So the first thing I want to do here is convert the improper fraction into a mixed number, and that's going to make these all look pretty similar. It'll be a bit easier to compare them. Okay, so to do this conversion, to make this improper fraction into a mixed number, you just want to do some division. So 28 divided by 5, and you need to know how many are left over too. So 5 goes into 28 5 times. 5 times 5 is 25, so we have 3 left over. So when I divide this out, what I find out is the mixed number version is 5 and 3/5. Okay, I'm just going to replace my improper fraction now. I'm going to replace my improper fraction now with my new mixed number that I figured out. Okay, so I have all mixed numbers. Most of these numbers are pretty easy to compare because I just need to look at the whole number. That's the first thing that tells me their size. So obviously 5 and 3/5 is the greatest of these four fractions because it has the greatest whole number attached to it. 3 and 2/5 would be the next greatest. But then I have these other two fractions. They both have two whole numbers, and the fraction part's a little bit tricky to compare. So we'll talk about the other thing you have to sometimes do, and that's make your fractions equivalent fractions, meaning they have the same denominator. So remember a few lessons ago you would have been making equivalent fractions, and what you're allowed to do with fractions is you can multiply the top number and the bottom number by the same thing, and you don't change the amount, but you just change the type of fraction you're dealing with. So what I want to do is try to find a common denominator where I'm going to be able to do that little multiplication trick and give these two fractions the same denominator. So, and I'm just going to put the whole number part aside for now. We're not going to worry about that. We're just going to worry about the fraction part because that's what we're comparing. So we're comparing 1/3 with 4/5. And you might, just by imagining these, already know which one is the greater amount, but we're going to do the multiplication here anyway. Sometimes it's not clear just by looking at the fraction. There's fractions that you really can't tell which one's larger just by looking at it, and you do have to do this step. So I want to try to think about making a common denominator here so I can get both fractions the same denominator. So one denominator that I can for sure get to is 15 because for 1/3, if I multiply the top and bottom by 5, it's going to give me 5/15 as my new fraction. So 1/3 has been converted into 5/15. That's my new fraction. It's the same amount, just different form. To do that for 4/5, I'm going to multiply the top and bottom by 3. And my new number is going to be 12/15. So 4/5 has turned into 12/15. That's my new fraction. Same amount, just written in a different form. So this now makes it really easy to compare. So let's look at our four fractions and write them from question asked for least to greatest. So we'll go least to greatest. So the least fraction is, we have 2 and 1/3. We converted 1/3 to 5/15 to show that it's less than 4/5. So the least is 2 and 1/3. And then the next largest number is 2 and 4/5. Next largest number after that is 3 and 2/5. And then the greatest out of these four is 5 and 3/5. Okay, just to review everything that we just went over. So you really have to think and be clever about your strategy for these. So option 1, use a number line. So draw a number line that's going to allow you to place each fraction you're looking at on the number line. That can be very helpful. Option 2 is to use equivalent fractions. So it just basically means make all the fractions the same type. And there's two different things you may have to do. You might have to convert improper fractions to mixed numbers. Sometimes you may wish to do the opposite. You might be converting mixed numbers into improper fractions. Do whatever's going to make the problem simpler and whatever's going to cause you to have to do the least calculating. Also, you have to make common denominators to compare different fractions. So I said earlier that some fractions are really similar and you can't tell just by looking at them which is greater. This is an example. So we're looking at 3/8 and 2/5. I've even given you a diagram. Even with the diagram, we can't really tell which one of these is larger and which one's not. You might be tempted to say 3/8 is larger because those numbers are both bigger, but remember the size of the numerator and the denominator doesn't necessarily tell us about the amount that we're talking about. Because even though we have more pieces for 3/8, we're also talking about smaller pieces. I can't tell but just by looking at the diagrams. I'm not going to give the answer here. I'd like you to try to figure it out using one of the options that I showed earlier in the video, and if you are able to figure it out, please tell me in class which one is the greater amount, 3/8 or 2/5.